Okay, in this video, I'll go over the problem 2 version B problems. So the first problem basically gave you two graphical representations. They actually gave you f and f's derivative, which was pretty nice of them. So here's f, and then the slopes of f are represented as y values on this graph. So all the y values here are the slopes that you'd find here. So for example, at the top here, the derivative is 0, and notice at this spot, it's actually 0. All right, so once you know that you have these two things, that's pretty nice of them, because normally they don't give you both graphs. We can start seeing what the questions are. So A is to find the average rate of change on a certain interval, and then they want to know how many times the instantaneous rate of change matches that. So average rate of change is just slope over an interval. Instantaneous rate of change is the slope at a spot, or the derivative. They want us to write the equation of a tangent line, so this is a classic. Once again, it's not worth a lot of points, but they ask a lot, and it's easy to get if you know how to do it. The last two are more difficult because they expect you to know what these limits are, and so there's a quick way to answer these limits if you understand the structure of them. And then here they ask us to find the derivative of g, and they define g in a weird way. They sort of have g involve e of x and f of x, and then want us to find it. So they define a new function at the very end that they didn't talk about before, but it's based on f. All right, so to go through these problems, let's get the answers to each one. So A just wants the average rate of change on the interval 4 to 1. So it's the slope. You just need f of 4 minus f of negative 1 over 4 to negative 1. Make sure, I think I said 1. It's from negative 1 to 4. All right, so make sure I'm speaking precisely. So that's the slope, or the average rate of change. If you calculate that, you should get 3/5. So there's only 1 point for that, but it's not really that hard to do. Just be careful. Make sure you don't make any mistakes, because any little mistake, you won't get the point. Be sure to answer the second part. They just go how many times does the instantaneous rate of change on this interval match the average rate of change. Now, there's a theorem, the mean value theorem states that if f is continuous and differentiable, that there's going to be at least one spot where on the interval where the derivative matches the average rate of change. Now, you don't need to cite the MVT here, the mean value theorem, but basically the mean value theorem's going to guarantee, because this is continuous function, it's not smooth at this spot, but for most of it on the interval that they're talking about, negative 1 to 4, basically at least you got the continuity. So basically what's going to happen is there should at least be a spot where this happens. There's actually two. So keep in mind that since the average rate of change came out 3/5, we want to know how many spots does the derivative, so when they say instantaneous rate of change, how many times does the derivative actually come out as this value? Well, there are two values where the derivative is 3/5. You can get that right off the picture. If you take a look at the derivative, here's the derivative. It hits a y value of 3/5 would be somewhere in here. So it's hitting 3/5 once, it's coming back and hitting 3/5 twice. Then it's up here, and then here's that one spot where it's not continuous anymore, or I should say it's not smooth here, so it's not continuous on the graph. So it jumps down, and it doesn't have to pass through 3/5 again. So basically there's two spots where it hits 3/5. All right, I'm just getting that right off the graph they gave me. So that gets me a second point. So getting 3/5 and realizing the derivative equals 3/5 twice gives me 2 points. To find the tangent line, once again, only worth 1 point, but shouldn't be too bad. They give me, I believe that x is 1. So if x is 1, I could just figure out that y is 2 off the graph, because they gave me, I can tell that it's 1 and y is 2 right from the graph. So I have the point. Now I just need the derivative. Well, I can get the derivative right off the picture as well, because they want me to find the slope of the line at the x value of 1. Well, if I want that, I can go back to the picture and go, well, what happens at 1? Well, the slope is negative 2. So all of this just comes graphically. So I got the point graphically, And using the graph of the derivative, the slope is the derivative at the x value. The x value is 1, so the derivative at 1 is -2 based on the graph. Then you can just plug it in. The slope is -2, and the point was 1, 2. So there's your tangent line. In C, these are actually easy to answer if you understand what these are. This is the definition of the derivative. Remember, there were two definitions. There was one where h approaches 0. There was one where x approaches a. Basically, the definition of derivative is the limit as x approaches a of f of x minus f of a over x minus a is basically the limit of the slope. Since a is that value 2, this is basically asking what's the derivative at 2 and what's the derivative at 3. If you understand that, it's actually pretty easy to answer then, because this means what's the derivative at 2, and you can just get that off the picture. If you go to the derivative picture and find what's value at 2 is, well, it's 1. And what's the value at 3? Well, that's the spot where it's jumping, and there is no value. Notice there's no solid dot here, and there's that jump. So it doesn't exist. So there's two reasons you can say it doesn't exist. You can either say, well, it's undefined on the graph of the derivative, or if you look at the original function, it's sharp there. F prime doesn't exist here because at this spot, it basically has that sharp turnaround, and we can't say what the tangent line is there because basically on one side it's 1 and on one side it's -1. Since they don't agree, it's not smooth and we don't know what it is. So there's a few different justifications you give, but basically the answer to this is, what is this limit? It's the derivative. Derivative of 2 is 1. Derivative at 3 doesn't exist. The last problem is to find g prime of 0. Basically, to find g prime of 0, I need to find g prime. G is this e to the x f of x. This is a product. So when I was looking at people who do this, the people get it wrong. Normally you don't get any points because they didn't remember to use the product rule. This is two functions multiplied. You got to use the product rule. So derivative of the first, remember e to the x is its own derivative. So derivative of the first is e to the x. Leave the second one alone. Add the first one, and then the derivative of the second one, the best you can say is that's f prime of x. So that's the derivative of f. This gets you a point because you use the product rule to get g prime of x. So now it wants g prime of 0, so plug 0 in for x. Well, 0, 0, 0, 0. E to the 0 is 1. F of 0 and f prime of 0, you can go up and get off the graph because you can get the y value. So f of 0 is 3, f prime of 0 is 1. Put that all together, you get 4, and there's your last point. Now, usually AP problems are 9 points. For some reason, this one I think was 7. So whatever, they're weird sometimes. Anyway, keep in mind normally it's 9 points, but this one, like I said, it was, I think I'd point out all the points. So basically on this last one, it was the product rule and the answer. This one, it was 1 point for each answer. And then I think I mentioned one for this, and one for this. The second problem was a table problem, and keep in mind it had the actual passenger function. So it wasn't giving you a rate of change, it was just giving you the regular function. So there's a certain number of hours that go by, there's a certain number of passengers that are on the ship, and they do say that the function is differentiable. So since this is differentiable, it also implies it's continuous, and that's going to be important a little later. All right, so keep in mind that that word right here is actually pretty important. All right, so we have our hours and how many passengers are on the boat. What are they asking about? Well, just talk quick about what each question wants. A wants the average rate of change, so hopefully once again that's a slope. That shouldn't be too bad. It wants it from 1 to 8, so we can get that by just doing slope. That problem should be pretty easy. It wants P prime of 4.5 written as a difference quotient, limit of a difference quotient. This is the definition of the derivative. So there's one of two ways to write this using the limit definition of the derivative. This is a little weird to ask, but that's what they're asking for. That's kind of difficult if you don't understand or don't remember the formula, but remember you got open notes, so I would write the formula down so you have it available to you. Then they want to approximate what's the derivative. So once again, we can use average rate of change. 4.5 is on this interval. The slope of this interval is going to be the best guess for what the derivative of 4.5 is going to be. Part C, this is basically asking, is there time, does there have to be 500 passengers on the boat at some point? This is an application of the intermediate value theorem. This is why we have to know this thing's differentiable, because if it's differentiable, it's continuous, and then if it's continuous, the IVT will apply, and we'll be able to answer this question. And the very last part of this is going to involve this g function, which they, once again, introduce at the very end. They give you what this g of t, and then they basically want you to find g prime of 4. So they're basically giving you, what's its total numbers of gallons the passengers use. So this thing gives you the total number of gallons the passengers used over time, and they want to know what's the rate at which people are using the water after 4 hours. All right, so this is going to require find the derivative and plugging in the 4. So let's look at the answers to that part. So 2A wants the average rate of change. I had to be careful when I read the problem because I did it and then realized I picked the wrong, I picked 0. They want from 1 to 8, so this is f of 8. This is f of 1, 8 and 1. Do that, you get 99. They want the limit of the difference quotient, just a fancy way of saying represent the derivative by its definition. You could use this one or this one. This is the x approaches a definition, so the definition of the derivative in one version is limit as x approaches a of f of x minus f of a over x minus a. In this case, the a is the 4.5. So if you plug that into that formula, there's an answer. The other definition of the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. In this case, the x is playing the role of the 4.5. So in this one, a is the 4.5, here it's the x, but make sure you plug that in. So either one of these, if you evaluated these, you would get the instantaneous rate of change by definition. All right, so these are a little tricky because they're going on that definition of the derivative. The part that's easier is finding the derivative 4.5 is basically, they want an approximation for it. So you're just going to use the slope on the interval. It's the best you could do. The slope on that interval is f of 6 minus f of 3 over 6 minus 3. Comes out as 132. The question that asks, are there ever 500 passengers? Well, keep in mind, since this is continuous and increasing, we're just getting samples of it, but it goes from 204 to 600. In order to do it continuously, it's got to pass through 500. That's basically what the intermediate value theorem says. So you should mention something about the intermediate value theorem, which is abbreviated IVT. Now, when I did this, the first time I accidentally put MVT and I meant IVT. So it's a little scribbly on my work here, but so there it is, IVT. So that's supposed to be an I, because like I said, I accidentally put MVT the first time I did it, because I do these myself before I look at the answers to make sure everything matches up. So on this point, I accidentally wrote the wrong thing, even though I was thinking that. So anyway, part C. So does there have to be a time when the passenger's 500? The answer is yes. Basically, since the passenger function is differentiable, the passenger function is also continuous. If the passenger function is continuous, then the IVT applies. Basically, what the IVT says is, since 3 gives me 204 and 6 gives me 600, as I go from 3 to 6, I have to pass through all the values from 204 to 600. So that means I have to pass through 500. So the IVT guarantees that there must exist an x value that's in this interval such that when I plug in that value, it gives me 500. So there's some time between 3 and 6 where I must have been at 500 because 500 is between those two y values. So basically, in order to get from 204 to 600, I had to pass by 500 somewhere between 3 and 6. And that's only true if the function's continuous. Since it's continuous, you can just basically picture it's like, oh, I'm at 204, and I have to get up to 600. So as time goes on, I must, no matter what this thing does, it's got to hit 500 somewhere in between. Even if it goes up or down or up or something, it's still continuous, so it's got to cross through 500 somewhere. All right. Then that last problem, they gave me G of T. This is the amount of gallons the passengers use. It's defined for 0 to 8. Basically, I just want to know what's G prime of 4. So what's the rate at which passengers are using water after 4 hours? Well, take the derivative of this. Be careful that you have to use the product rule. I left the 120 out here and then did the product rule on this thing. So derivative of t, leave that alone, t, derivative of this, remember this is t to 1/2, so its derivative is 1/2 t to the negative 1/2, which is 1/2, t to the negative 1/2 is square root t in the bottom here. So here's my derivative. What's the derivative at 4? Well, plug in 4 to these values. Good news is square root 4 is easy to evaluate. This is 2, and this is 2. So I get 2 plus 4 over 4, which is 1. So 2 plus 1 is 3, and 3 times 120 is 360. Basically, if you got a calculator, you could also evaluate that. They're not taking the calculator away from you. All right, and then I'm not sure if I talked about points. So it was 1 point for the 99, 1 point for one of these two definitions, 1 point for finding the 132. The MVT, now they screwed this up on their own key. On the computer, if you did it through, if you did it on the computer, they said it was worth 2 points, but they only assigned 1 point to it in the grading system, so it was weird. It should be worth 2 points. Like I said, if you go back and look at it, if you did it on time, you'll see I can only award you 1 point for it, so it's a little weird. And the derivative here with the product rule is worth a point, and then finding the value is worth a point. And remember, I actually said using the calculator, once you get this thing with all the numbers plugged in, this is actually an answer, so you could just leave it this way instead of risking making mistakes simplifying it. Okay, so that's the two. That's those two problems. So we looked at one that once again had graphs, and one that had tables. So hopefully you're starting to see a pattern that they like to, once again, ask things either graphically, through table, or through analytic functions. Even though these were primarily table and picture problems, they did give you some analytic stuff. Just g of x is defined as an analytic function, and so was g of t in this problem, an analytic function. So they have all three different modes in here, all right? So those are the answers and point values for that problem 2B. Be on the lookout for future videos.